So now we're going to build a very simple browser and server in Python. Okay, so import a library, import socket, and that just like, import math or import whatever, that pulls in a library into Python. Sockets are built into Python. It's very cool, and it's very, very simple. So sockets kind of function like files, but they're files that we can send data to and receive data to. But when you're using a file in Python, you've got to first open it. And so the opening of a file, of a socket, is really a two-step process. First, you create the socket, and that socket sort of lives in your computer as an endpoint that's not yet finished. It's the endpoint that you're going to send and receive data to inside your computer. But then we have to actually make the phone call. So socket.socket, and don't worry too much about this syntax, we don't change it. Socket.socket basically says make a phone. That's what we're making. And then mysock.connect, that second line, is dial the phone. And we're dialing the phone to a domain name, data.pr4e.org, and a port in that domain name. So that is the call. Now, if we made a mistake, right, if we were dialing and not talking to the right server, or that server didn't exist, this connect would blow up, meaning we'd make a phone call, a data phone call to a server that doesn't exist. That line is what's going to blow up. But as you continue down to the next line, if it gets that far, now you put try and excepts around this if there was but I want to keep this really short, so I'm not putting in all the stuff, all the error checking. So connect might blow up. Socket.socket won't blow up because it's like, unless you don't have networking at all in your computer, but it's unlikely these days. But mysock connect is like dial the data phone to this endpoint, and it includes the port 80 that we talked about before. And now we need to send a command. And in this command, it's exactly what we talked about before. It's exactly what we sent via telnet. It's a get, followed by a space, followed by our URL, followed by a space, followed by a protocol HTTP/1.0, and then we hit the enter. Now it turns out in network world, you actually hit two things. It's the /r/n is a return and a new line. And you have to hit it twice, the enter at the beginning of the first line, and then remember we had to put that blank line in because to say no headers. Now we would put in between here, we'd put all our headers in there if we were going to do that, but we're not going to do that. And then you have to use encode, and encode means that the data sent across the internet is generally sent in what's called UTF-8. Inside of Python, the data is in Unicode, so that you can put literally any character in a Python string, and then preparing it to send it out across the internet, we kind of encode it into the more dense more compressed UTF-8 format, rather than we don't send strings across the internet in Unicode in general. I mean, it's very rare, but you'd have to control both ends. We want to send them in UTF-8, and so the string get blah blah blah, that's in the Unicode string in Python, and .encode says convert this into a UTF-8 string, and so command cmd is a variable that has a UTF-8 string in it. And then we say send. Now remember I said that you can simultaneously send and receive on these sockets, but the protocol tells us whether the first thing we're supposed to do is listen or talk. And we're the browser in this case, and so we're supposed to talk first. So we send the request out, and that's just like you typed it in Telnet, because in effect you're scripting Telnet. We liked Telnet in the old days because it was kind of like a socket. I could connect to any host, any port, and type things and see if it's broken or not. And then the protocol says once the server has received the first line, any headers, and then the blank line, then it's to return it. So then the next part of this is we're going to have a little loop. So the protocol tells us we are supposed to receive data until the socket's closed. And at the bottom of that telnet, you saw that it sent a bunch of lines, like 4, I think, and then it closed it. That's what's going on here. We are retrieving data, and then this receive, this actually waits. If the server is coming slow or the network is slow, this piece of Python will be sit. Oh, got a little bit, up to 512 characters. It will wait until it's gotten 512, or it's done and it's got 100 or so. But the receive is a blocking, waiting operation in Python. says, give me up to the next 512 characters. Now, usually the network's so fast that the Python doesn't even wait because the operating system already has it. But we get it, and if we get no data whatsoever, that is our indication that the network connection, the socket has been hung up on, closed by the remote server, and away you go. So that's why we are going to break if the length of the data is less than 1. And if not, we're going to simply print out the data, but we're decoding it. And that's because the data that comes in is in UTF-8, but the print statement wants to print Unicode. And so decode says, here's a variable that has UTF-8 in it, convert it to Unicode for printing inside of Python. So because this data is externalized to us, we encode it before we send it, and we decode it when we receive it before we use it, because Python inside itself doesn't use UTF-8. Python inside itself uses Unicode, which is awesome and a whole separate conversation. I'm just kind of bringing that up to remind you how important it is, because we're not going to write much of this in Python, really, and all this stuff is taken care of for us in web servers when we get to that point. But it's just a good time to review Python's strings and Unicode and encode and decode, because it's really important. So if you run this and you've got it right, it runs pretty simply. Let's get the color back. Get it back to yellow here. So if you run it in your system, Python socket1.py, it will, all the work is done up here before you see your first output, and then all this output that you see is just this loop running. And what you see is really the exact headers that are coming from this server, and then you see a blank line, and then you see the actual page that's coming out. And you don't see it, but at the end here, the connection gets closed, and you break out, and you're done. And then we close our end of the socket. The far end was already closed. That's how we know to stop reading data. And then we hang ourselves up so that our local system does not end up with a bunch of half hung up phone calls. And so that's basically how we talk to a socket in Python. Now, that was literally 10 years ago how I would debug applications. I would like telnet or write a little thing like that and dump all the headers. And that got really tiring, really boring, really tiring. And so browser developer mode is going to be your friend. In a way, browser developer mode, and I'm going to have a separate video on this, browser developer mode lets you look at the sent headers, the received headers, the received data, the sent data, what URL it went to, and it's super awesome, especially because a lot of web pages have like 40 to 150 request response cycles. So you don't want to debug them all by hand. You just let the browser do its thing and say, what was that second one and what went wrong in the second one? I spend a lot of time when I'm debugging web applications using the developer mode, and that's why I have a special little video that gets you familiar with it. And I tell you, by the time you've done web stuff for a little while, you're going to know your browser developer mode. So next we're going to talk about writing code in the server to respond to these requests. So we build a browser in Python. It's time to build a web server in Python. So remember that what we've got here is we've got, the browser is an application, and we've made this a Python application now that sends this GET request. So we have effectively, like I said, built the world's simplest browser, and that sends a GET request. The server does something, and then it sends the response back. And now we're going to kind of change this, right? We're going to assume the browser exists, and it's like, okay, because we're going to be the server folks, right? So now we're going to look in greater detail at what goes on in the server. And so here is a very, very simple web server. It's a few more lines than the simplest web browser, because we have to put a little bit of error checking in with some tries and accepts. Okay, so let's walk through what this code does. Okay, let me change the color again to black. If you're from Microsoft and you can tell them to make a key to change the color on the scribbler, I'd greatly appreciate it. Oh, and then I went down a page too. Okay, so we're going to pull in some more stuff from the socket. We're going to pull in some stuff from the socket right here, and so we're going to make a function called create server that we're going to call right down here. and it's going to print out how you're supposed to access it, and then start the server. Now, the whole idea of the server is the server is woke up to wait for incoming connections. So the server already exists. So when you start talking to a web server, that server's in that computer already. The server software is already running, registering its interest in incoming request. So that's what we do. So when this Python program starts, it's going to sit there and wait in an infinite loop for incoming requests. So the first thing we do is we're going to make a socket. This looks very much like the time we made. It's an endpoint. It's not actually making the phone call. Remember I said this socket call is making the phone. So we're saying we're going to make a phone, and it's up to us later to decide if we're going to make a phone call or receive phone calls. And then this next thing is like the connect, except this is I am willing on port 90 to receive the phone calls. Now, it turns out there's only one program on port 90 that can receive phone calls. So this might blow up. You might try to do this, port 9000. And if you run this twice, and you can do it in 2 windows on your computer, the second one will blow up and say, you can't have port 9000 because another piece of software has it. But as long as there's only one running, away you go. And that's part of this whole try except thing, because if you run this twice, going to blow up the second time because you cannot receive phone calls on this server on port 9000 with 2 applications. One application gets the phone calls. That's what socket listen says. The 5 on there says, dear operating system, if I'm busy handling 1 phone call, you can hold on to 4 more and queue them, and then I'll come back and get them for you. And that you're asking the operating system to queue incoming calls. Don't just say you're busy, shut down. If you didn't say this, listen 5, if you were busy writing the data for phone call 1 and phone call 2 came in and you weren't ready for it right that instant, it would just deny the phone call. So that's what listen says is, dear operating system, hold those temporarily, I'll get back to you, which is how it works. And then what happens is we go into this accept. Now this accept is, I'm at the phone, I've registered what my number is and what my extension is, and I'm ready to pick the phone up. Let me know. So this accept is blocking. It stops and it just sits there, and it can sit there forever. Just literally forever. If nobody calls it, nothing happens. The next line never runs until you blow it up or the server goes down. So that accept is a blocking. And the reason we do this accept, well, we have to establish the phone call first, right? So then this next line runs only when a phone call is received. So that means that on the browser side, we already connected, we made the phone call. Now we haven't sent any data yet, right? And so this is just now, at this point, somewhere out there's a piece of client software that has done a socket.connect, and we have done accept, and our accept has succeeded in the server, the connect has succeeded, and we are ready to talk. So the phone call has been made. Now the question is, who's going to say hello? And this is where the HTTP protocol solves our problem. The server knows that the client must speak first. So it just does a receive. Now you'll notice the receive and the send are the same function calls because it's a two-way thing. Whatever the browser is sending, the server is receiving, and whatever the server sends, the browser receives. And they can do it simultaneously if they can figure it out. But usually you kind of like say, it's your turn to listen and my turn to send, and then I'll listen. And usually they kind of go back and forth. In this, there's only one step. The server listens, gets the GET request, sends the data back. And so then we're going to read some data, and we're going to get 5,000 characters. We're going to get the whole thing. Remember, it's one line. It has a GET request in it. It has the optional parameters in it. And so we're going to split it. Now again, we've received it as UTF-8. We've got to decode it for UTF-16. Not UTF-16, Unicode inside of Python. And then we split it based on new lines because the GET request is on one line, then header, 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 and then the blank line to tell us that we're into the headers. And we're only going to take, in this, we're just going to look at that first line. We're not going to do anything with it. Most servers actually look at the line to figure out what document to send. It's a very simple server. It sends the same document no matter what the URL is. All we do with the URL is we print it out to prove that we got it. And then we construct a response. And in this response, again, go back to RFC 2616 and it will tell you what this response is supposed to look like. It sends back a 200 OK. Remember, this is all the stuff we saw. Probably I cut and pasted it from a working thing. We tell it that we're sending it back in content type 8 text HTML, the character set UTF-8. Remember I was telling you that. A blank line, and then some HTML. HTML body, hello world body. And I'm throwing in these /r/n's, which is the network's version of new lines. And then you will notice that I encode it before I send it because it's Unicode inside of Python and it needs to be sent as UTF-8 because the phone, when you're in a socket, the thing that's going across the socket almost always is supposed to be UTF-8. So we encode it. And then because the protocol says so, as soon as we send the data, we close the connection. Now remember that the client had to close the connection too. So we close it, it's half closed, and then the client gets all of its data, gets the indication that it closed, knows it's finished all the data, and then the client shuts its side down. And so there are two hang-ups. It's kind of like a phone call. The person hangs up, and then click, you hang up. Now you can't really keep talking, but you do want to have both sides hang up, and that shutdown is what's going on. And then the rest of this is all try except for various things. So we clean up our socket so we don't have to restart our server when our software blows up. And so the rest of it's pretty simple. And then, so this while one, the first browser will talk and then it'll send some data and then it'll go back and wait for the next phone call. And that's what's going on. The next phone call comes in, it sees a GET request, it sends the data back, then goes and waits for another phone call. So this is an infinite loop that sits and waits for incoming phone calls, and it answers the same thing. So it's like you call this phone number, and it goes, and you go, I would like a pizza, and it says hello world, and then click, and then you call it up and say, I would like a car, and it says hello world, click, and then you say, I would like to register for this class, and it says hello world, click. So this is not a very flexible server. You will build far more flexible servers. But it's the one I could build and fit on a single page in a slide deck. So to run this, if you you download this code, and it's a tiny bit of code, and you run it, so you go somewhere, maybe your laptop, maybe Python Anywhere. I don't know if it works on Python. It probably doesn't work on Python Anywhere because you can't actually talk to ports. But let's just run this on your laptop, and you start the server up somewhere, get a hold of my sample code, or download it from here, server.py, and it's telling you this is just output from the server. And this is the moment at which it's waiting, right? It's waiting. The server could wait for hours at this point. But I just give you this in a print statement so you can copy that and put it into your browser. So you paste localhost 9000 into your browser, and then the server is printing that it got a GET request for the / document from this browser. That's what the browser sent. I mean, we're talking from Firefox browser to the little web server that we just built. Now there's a second GET request that you don't even know because you didn't ask for it, and that's because the browser is built in to ask for a URL called favicon.io so that it can make an icon, and that icon ends up in the tab or wherever in your browser. And so that's like an icon for the website. So you didn't ask the browser to do this, but it's a thing browsers do. And you'll see when you're looking at your debug logs, when you're building stuff, that it's a favicon. And so this happens like blink, blink, and now it's waiting again, right? And you could hit refresh, or you could go start a different browser, and you would see these GET requests. Every GET request you're going to see in your browser and your server. So it's working, and it works really well, and you're welcome to go ahead and play with it and try it all out. So now what we're going to do is build a simple web client, and then it'll talk to our server. So the other web client we made, talk to data.pr4e.org, this one is going to talk to yourself. So it almost looks identical, right? We're going to make a phone. We're making a phone. We're going to connect to localhost 127.0.0.1 is the IPv4 connection, what's called loopback, right to the same host. We're talking to port 9000 because that's where we've got our web server running, that little web server we just wrote. And then we're going to send a GET request, a valid GET request to this thing, HTTP10, and then 2 new lines, and we're going to encode it into UTF-8 before we send it. Then we send it, and then we just have a loop that prints it all out, and then when the socket gets closed, we hit a break, and then we close our end of the socket. So the server clicks the phone, and then we're done with our data, but we've already printed it out, and then we hang up the phone on our end to kind of clean everything up all the way in between everything else. So this is a very simple web client. And so now you can run the web server, right, just like we did before. And instead of talking in a browser, we run this client. And this client gets a header of HTTP 1 OK, it's content type HTML, it gets a new line, and then the body, and we're done. Now, I mean, it's not a browser, but it is a client that's talking HTTP. And so now you'll notice that this server sort of sits and waits for incoming calls. You could run this over and over on the client, run the client over and over again, right? And then you would see more requests. But in general, the server is destined to just sit and wait for hours potentially until a client connects to it. And then at some point, you'll just abort this server. And then if you Control-C or blow this up somehow, this will fail. The client will fail, and it will fail in this connect code. So if you want to play with it, try to run this client without running the server, and you'll see that the connect, which is the part of actually making the phone call, this will continue to work, which is make me a phone on my current computer, and then connect is make a call to the remote computer. That will blow up. And then if you wanted to play with this, you could put some try and accepts around it, say remote computer is not responding on port 9000. That's if you blew up. You could put a try and accept around that. But I'm not doing it because it don't fit on my slides. So here is an even simpler web client that we can use. And again, you can get this code from my sample code. We don't talk to this. There's a higher level thing that the previous client talked to sockets, so I could show you the low level. But because we spend so much time talking about to URLs, we then have a URL lib. So I'm just going to use URL lib. And this could be a local host or it could be whatever. I'm just going to make a 4-line URL lib call. And so I just do a URL open of that same URL. Now we're operating at the HTTP level because the concept of URL is not a socket concept. The concept of URL is HTTP concept. And we just get, in effect, what looks like a file handle to us, and we loop through it and print it all out. So we run our server, and the server sort of says this and waits. And then when we run our client, it basically hits our server, and we can see in the server window. You got to do these two things in two windows, right? You got to do these things in two separate windows. So in the server window, it'll sit and wait, and then in the client window, when it runs, you'll see the client will make the request to the server, or blow up if the server is not running, and the server will see the GET request, and then the data will come back to the client. So you sort of do this in two things, and you can run the client over and over and over again, and you'll see every time you run the client, the server sees it, responds, and away you go. And again, our server always says hello world no matter what, which is delightful and classic. It's a classic. So you actually can watch when you're running Django. There will be a way for you to see when you're running Django locally. You start the server up. This we'll do this later. Manage pi.run server, and then you talk to it, and you will see all the GET requests. And so Django, when you run it locally, you can debug a lot of what's going on. So you can see like the favicon that it's asking for, and that is 5 or 6 HTTP requests to produce that little Django web page. And so that will be something that you will learn how to do. And so that sums up what we're doing in this. At the beginning, you look at it very simply. Pretty soon, you'll just be looking at the developer console, and it'll all make sense to you. I want you to be able to know that you can dig as deep as you want to and understand all of these protocols that are going back and forth. Okay? Cheers. Hello, and welcome to another walkthrough for Django for Everybody. In this walkthrough, we're going to talk about the browser debugger console. And so this is something that in the old days was only in Firefox, but eventually everybody built it in, and you used to have to build a plugin. and it shows up at different places. And so in Firefox, it's here under Tools. It turns out that you can kind of go to any of these things because these are the, you know, they're just different tabs here. In Chrome, we do View, Developer, JavaScript Console, and then you see a similar kind of thing here, right? So I'm going to do it in Firefox here. And so you can see things like, you can see the document object model, you can see the JavaScript console. This little error hardly matters, it's because it's such a simple page. You can actually debug JavaScript code, you can watch the network, you can play with CSS, etc., etc., etc. Performance cookies are in here. So there's a lot of things that you can do. I'm going to start and show you right now. We're at the very beginning of class. I'm just going to show you some of the most basic things here. I'm going to clear this out and then refresh the page. And so what you see here is you see each request response cycle, right? And so I came up here as if I type this. Let me clear it again so you see it. I'm going to type this. I'm going to press enter. And that tells the browser to go retrieve this page. So it connects to the server, www.drchuck.com, and gets the document page1.htm. This favicon.ico, that's basically getting this little favicon right here. That's the little thing that shows up in the tab bar. And so websites can have a file, and later we will actually make a favicon. But what I want to show you from a request response cycle is you can see some detail here. So let's go up here and you can see detail. You can see that this was the URL. We sent a request, a GET request. We got back a status code. The status is the first thing. 200 is an OK. 404 is not found. And we used HTTP version 1.1. The request headers, they always show you the request headers, response headers first. So these request headers are actually part of the HTTP protocol where we are telling things like what my preferred language is, what kind of documents we can handle, you know, and cookies that we're sending back in. We'll learn more about all of this stuff. And so this is actually when the browser makes the connection to port 80, sends the GET request to the URL it's interested in, GET http www.drchuck.com/page1.htm space http 1.1, and then after it sends these, and this is pretty much the format, accept colon blah blah blah, and so that is and then it sends an empty line, and then it's done, and then the browser sends back first a set of headers. You know what, the content type is very important. The size is sometimes in here. gzip means that it compressed it on the way, and so these are the response headers. And so if I go to an error page, not a page.htm, so I'm going to clear this, and what's happening here is it's putting up a page from my hosting system. But the most important one here is this, and that is the 404 error. And so it was going and it sent a GET request to http.drchuck.com, not a page.htm, and it got back a 404 not found. So that was that 404 not found is a different status code that said this is a thing that's not there. 500 means the server had an error, and we'll talk about all these codes. But the point is you can debug all this stuff quite nicely. So let me go back to page1.htm. So let's clear this and refresh it to make sure we got it all right. Okay, so we grab the page. And now I can, another thing that you probably by now have figured out to be able to do is inspect element. So now you're actually looking at this document object model, right? And so this document object model is not necessarily the code that came back from the server. If I go here to network and I click on get, and I look at the response, this is the response down here. This is what actually came back from the server. And then the browser parses this and turns it into what's called the document object model. So this is the source. Now, just as for fun here, you'll notice that I can change the document object model here, right? If you are cool, you can switch to the second page. So you'll notice the document object model changed, and what I saw up here changed as well. And so this is like inspect element. I can do something like, I can even add here, I can add some CSS, style equals color :red semicolon. And if all goes well, there you go. You see I switched the color. This is the document object model. Now the server was completely uninvolved in that. And later we're going to write a lot of code to mess with the document object model. So the server is still, it doesn't have the red in here. It didn't change this to cool. So this is what we originally got from the server. And this is what we've got in the browser. And so once that page comes from the server, you or JavaScript can mess with that page. So it's pretty dang cool. Okay, so now I'm going to clear it, and I'm just going to click on this second page, which is an anchor. Let's inspect it. Well, it's an anchor tag, and so it's going to do another GET request. And so this time it went and grabbed page 2, and there's the second page. And you can go back to the first page. And so there's a lot of things that you can see. This persist logs is an important feature. That means that it keeps them crossed more than one request, and disable cache means that sometimes the browser wants to keep a copy of something, and you, while you're debugging, you want to say, hey, go get the original every time. And so this, right now I'm starting you on very simple pages, but if you take a more complex page, and I can never remember where it is, view developer network, let's go here. If you take a more complex page with a bunch of things in it, and you hit refresh on this page, you will see that it does a GET request, but then as it parses that GET request, it finds things like all kinds of stuff, right? So here this took 44 request response cycles, 1.6 megabytes, and it took almost 1 second to download all that stuff, right? It took a second to download it. And so if you scroll all the way up to the top, the original GET request was to this URL, which is /lessons/rrc, which is the URL. But then if you were to look at the response, and I don't want to see that, I want to see the actual HTML. So if you look at the response, you see all these URLs for more stuff, some CSS or from JavaScript, some who knows what. And so then what you see is it then retrieving all these other things that it needs to actually construct the page. Some CSS, grabbed a font, it grabbed jQuery, it grabbed time ago. That's a little thing like, and then grabbed a bunch of JavaScript and fonts and this, and then the translate. So you see this little translate thing? It's doing that. And so you'll see that's how it quickly builds up to about 44 request response cycles to produce a page. Now, so that's just my quick introduction to this. You may not see these little drop downs like this. You might have to turn them on in preferences. So you go into preferences somewhere. I turned them on a long time ago. I probably couldn't even find it, but you might see it. The other thing that I would suggest is don't use Safari, because Safari's trying to hide too much stuff. Like it doesn't even show you the URL unless you click on it. So Safari's kind of a pain in the neck. And so I would suggest that for this class, you either use Firefox or you use Chrome in addition to using Safari. Safari is fine for daily use, but I just find it as a debugger, it's bad, which is really sad for Safari. They made Safari unfriendly to software developers, which means we're not going to test our stuff on Safari, which means if it breaks, too bad. Okay, well, enough of that little Safari diatribe. Again, I hope that you found this walkthrough for Django for Everybody, as usual, helpful. Cheers.